Hello everyone, welcome to another video. In this week I want to revisit the AKS GitOps extension for Flux. I'm saying revisiting because one of the first videos I made on this channel with a colleague back then was about the GitOps extension and how we can use it to install our software on an Azure Arc enabled AKS cluster. It's been around 4 years since I used the extension the first time, and today I want to check what has changed, has it improved, what has changed, and if it's something I want to use more in the future. Before I start with the demo, just a couple sentences about GitOps if you're new to this topic. And GitOps is a great approach to manage your Kubernetes cluster. The idea of GitOps is that you have an agent running inside your cluster, and this agent pulls a configuration from a Git repository or a Helm chart. The big advantage of this approach is that you can lock down your Kubernetes cluster because you don't need access from the outside to deploy your applications. Because the agent from inside the cluster pulls the changes, and therefore the connection goes from the cluster to your Git repository and therefore also goes through the firewall, because it's an outgoing connection and not an incoming connection. The second great advantage of the GitOps approach is drift detection. This means if the configuration inside your Kubernetes cluster changes, then the GitOps operator will see this because the current configuration is different than the one in the Git repository, and then it will download the configuration and apply it again. This helps you to ensure that your Kubernetes cluster always has the configuration you want. When I say GitOps operator, there are currently two big open source solutions. The first one is Flux CD and the second one is Argo CD. Today I want to look into the AKS Flux extension. That's just a Microsoft flavored implementation of Flux CD. And in my next video, I want to take a look at Argo CD, also with the AKS extension. Before I get started, let's take one look at how all of this works. So on the left side, we have the developer workflow. Nothing changes there. So the developer creates a pull request into the application repository. Then you hopefully have a pipeline that validates the build, runs unit tests, maybe even deploys already to a dev environment, and everything is fine. Then you merge it to your main or master branch. Then you usually have a CI pipeline. This pipeline is running more unit tests, but also creates your container image. Then this image is pushed into a container registry. This could be the Azure Container Registry, like in this case, but it could also be Docker Hub or anything else. After this is done, then you have the CD pipeline. That's a deployment pipeline that's either triggered automatically or you can also trigger it manually. And what's important here is that this CD pipeline changes the configuration of the AKS cluster, and it uses a separate repository. It doesn't have to, but it's nicer to split the application and the deployment. In big companies, you also have different teams responsible for both. On one side, you have the development team. On the other side, you often have a DevOps team or system engineering team, and there you can completely split this. But in this case, we have a pipeline, and this makes some changes in the GitOps repository. In the simplest case, it could be just changing the version of the container you have. Or this could also be an update to a Helm chart or any other configuration you have. And then the interesting part is now here on the right. In our case, we have the Flux agent inside our cluster, and this agent checks the GitOps repository. By default, it checks every 10 minutes, I think. Today in the demo, I'm going to show you how we can configure this. But then the Flux operator sees there's a new commit on this GitOps repository, on this one here on the left, and then downloads all the changes. And once the changes are downloaded, for example, a YAML file or a Helm chart, then these files are applied. And therefore, you have a deployment on your Kubernetes cluster. As I said before, we can have here a big firewall in between that's blocking every incoming connection. But with the GitOps approach, it still works because the Flux operator makes an outgoing connection. Therefore, the firewall can block here all incoming connections, and this approach still works. And with this, you also have automated deployments without accessing the cluster itself. That's a lot of theory. Now let's switch over to the terminal and let's take a look how this actually works. All right, here in the terminal, first we have to configure a couple of things before we can get started with the AKS extension. The first thing is I already have the Azure CLI installed, but now we have to install 2 extensions. And if you already have them installed, you can update them. So to update them, use the AC extension update command, and to install them the first time, use AC extension add. And the 2 extensions we want to install are the K8s configuration and the K8s extension. It should only take a couple of seconds. The next, we have to register free service provider. This is something you have to do only the first time in a subscription. And before we do this, let's check if you already have them enabled. And we do this with the AC provider show. Then the name, in this case, it's Microsoft Kubernetes configuration. And then we give the output as a table, so it's easier to read. So once we execute this, then we have here the registration state. And here it says registered. Then we do the same for the Microsoft Container Service, which also says registered in my case. And the last one is the Kubernetes configuration, which is also registered here. If you don't have them registered yet, then you can use the AC provider register command. And as the namespace parameter, you provide the 3 namespaces you want to register. As always, I have the entire code on my GitHub. The link will be in the description, so you can just copy paste them and don't have to type anything I'm doing today. So with this set up, now let's define a couple variables. So the variables we are defining is a resource group name, then the location, then the name for our AKS cluster. Then here we have the name for a GitOps operator. That's the name of the Flux agent we are going to install. Then we also have a namespace in which we are going to install it. And I've here configured a branch name because I don't want to use the main branch. Therefore, I just created a new one, and I will leave this branch open on my GitHub. So if you're interested, you can take a look at how I tried it out, what I changed. And you can also use it to get started. So now with this variables defined, let's create a new resource group with AC group create. Then we're going to create our AKS cluster. Here I'm just creating the most basic cluster. I'm using AC AKS create. Then I provide the name of the cluster and the resource group name. This will take around 5 to 10 minutes. And once the cluster is created, we can start deploying our Flux extension. The cluster is created, and the last step is to download the kubeconfig with AC AKS get credentials, the resource group name, and the AKS name. Once this is done, we can now create our first deployment with the Flux extension. So let's clean this up, and I copy the command, and then we take a look what this command does. First, we're using AC K8s configuration Flux create. This tells Azure to create a GitOps deployment using Flux. Then we provide the name of our AKS cluster, the name of the resource group, then a name of the GitOps operator, and the namespace where we want to deploy it. Then the cluster type, in this case, it's managed clusters because it's an AKS cluster. But if you use an Arc enabled cluster, then you would use connected clusters. This means if you have, for example, a K3s cluster with Azure Arc installed, then you can also use this extension. Next up, we have the scope cluster. There you can decide between cluster and namespace. And this gives the permission to the GitOps agent. in my case with cluster, the GitOps agent has access to the entire cluster, but you could also say namespace, then the GitOps agent only has access to one namespace. Next, the URL to the Git repository, then the branch of this repository I want to use. This is especially useful if you have different environments, for example, a development, testing, and production environment. Then with the branch, you can configure what you want to deploy. The sync interval I set to 20 seconds. This means the GitOps agent checks every 20 seconds if there are any changes in the Git repository. By default, it's 600 seconds. This means 10 minutes, which is usually fine. But for the demo, it would take too long and I would have to wait too long. And the last parameter, this customization, is a bit complicated and we're going to take a look at it in a second. But this provides the path to a customization file. And this customization file then says what should be deployed. So here we just provide a name and the path. And lastly, we provide the prune equals true parameter. This means everything that's not inside this customization file will be deleted. This makes sense, for example, if I deploy something, then I change my application, remove some resources, and then a GitOps operator automatically deletes them. Also, what's interesting, the first time you start this, you get obviously a lot of text here, but the interesting part is down here in yellow. So I haven't installed the extension yet, and AKS knows this, and therefore it installs the extension. This is going to take a couple minutes, and once the Flux extension is installed, then it will install the operator. If I execute this command again, and the extension is already installed, then it doesn't install it again, obviously. So while this is running, now let's take a look at the customization file and how the deployment actually works. Here in the customization file, as you can see, it's very simple. First, we have an API version and it's of the type customize. And what's also interesting is here that it's still a beta version. I couldn't find anything or too much about the API versions. What I've seen is that it barely changes, and even though it's a beta version, it's very stable. Then the kind of is customization, and the interesting part is these resources. Here you can reference all the resources you want to deploy. In our case, it's just a YAML file with the name demo app, and I also have this demo app open here. If you take a look at it, it's just the most basic Kubernetes YAML deployment we can have. So it's of type deployment. I deploy in the default namespace. We have one replica. And if we scroll down a bit, I have here just a very basic container that's, I think, just an old .NET application with Swagger UI just to start and see if it's working. And all the way down, we have here a service, also in the namespace default, and of type load balancer. This means we will get a public IP address. We can access our container if we want and test if everything is working. So by now, it should take a couple more minutes. I will come back once the deployment is finished, and then we take a look if everything worked and what else we can do. The Flux GitOps extension has been installed and the agent also has been deployed to our AKS cluster. As you can see, it's a lot of text here. What's important is that I don't see anything that says error, and here it also says healthy. So on the first glimpse, everything looks fine. To check this, let's do a kubectl get pods. Since we're already in the default namespace, we should see our pod. That's right. So that's the GitOps demo. It's around 2 minutes old. This looks fine. And it's running. So all of this looks good. Now we can also check what our Flux configuration looks like and if it has any errors in the log. Therefore, we use the AKS K8s configuration flux show. Then we provide the resource group name, our AKS name, and the name of the GitOps operator. And again, here we also have a wall of text. It's, I think, the same we have seen before. So it also says healthy here. But if you have an error, this view is not too useful. So now let's switch over to the Azure portal and let's check what we can see there. Here in the Azure portal on our AKS cluster, if we scroll down on the left side, we will find the extension and application tab. If we click on it, we can see the Flux extension has been installed there. And we can also see it has the auto upgrade minor version enabled. But if we click on it, then the auto upgrade minor version is not enabled. So that's a bit confusing. But we can see here, it's installed, everything works. And on the left side, if we scroll a bit further down, we have GitOps here. And there you can see our GitOps operator. The most important part here is that it says compliant. If you have any error, for example, if the customized file can't find the files you have referenced, then we'll see here a warning or an error message. And if you click on this GitOps operator, you get more information, and it's way more useful than what you have in the Azure CLI usually. So for example, on the left side, we can click on the configuration objects. There you can see we have the Git repository configured, and we also have the app. That's the name of the customization file we provided. If we click on this one, we can see just some log messages. For example, type is ready and healthy. Health check succeeded. So everything looks good. And if you have an error message, you should see it there. There it would say, for example, file not found. The same with the source. There we have the configuration for our Git repository, what branch, if it's public or private. So if it is private, then you have to provide a username, a password, a certificate, whatever you need to authenticate. So on GitHub or Azure DevOps, for a private repository, you can provide a username and a personal access token. Or on Azure DevOps, you can also use a service principal, and you can provide it here, or you can also provide it in the Azure CLI with the HTTPS key and HTTPS user parameter. But again, you will see it in the code on the GitHub. So if that's something you're interested in, you will see it there. I will also link you the video I did the first time, because there I'm using a private repository. For today, we just keep it simple and use a public one. The last option we have here on the left side is the customization. Here you can see the customer's file we have provided. You can see the path and the name, and also all the information. What's interesting here is that it says the sync interval is 10 minutes, even though we configured 20 seconds before. So I think there are two different options. The first one is for the entire Git repository, and this one is for the customer's file itself. But I have to admit, I'm not 100% sure about this. Also, what's interesting is if I change something here and want to save it, it doesn't let me, because the value it has here can't be 0, even though Azure suggests 0 and has 0 configured right now. By now you might already hear that I'm not too happy about this extension. Like, yeah, it works, but it has some quirks. Especially, I used it the first time 4 years ago, and it seems like nothing has changed. So it doesn't feel like there's much of a use to use the extension over the Flux itself. So I could just download from GitHub and install it myself, and I don't need this Microsoft extension. But for now, let's continue with this video, and I will give you my opinion at the end of the video. So let's switch back to the terminal and let's change our configuration. Our application is deployed, everything works, but now we want to simulate that I changed stuff in the configuration and I want the Flux operator to see this and apply the changes automatically. So first I'm going to set the replicas to 5, and then if I scroll all the way down, I change the type of the load balancer to cluster IP. This means that my app is only available from inside the cluster. Then I commit these changes. Let's call it changes for YouTube. We commit this and we push these changes. Now within the next 20 seconds, the Flux operator should see that there's a new commit. Then it will download the new commit or the new changes and apply them. This means in the next maybe a minute, we should see more replicas and the service change to cluster IP. Now let's switch back to the terminal and see if we already have our 5 replicas running. Here in the terminal, let's clean this up and do a kubectl get pods. Here we can see we already have 5 pods running, and we can see 4 of them are 1 minute old and the other one is 11 minutes. This means we just automatically deployed 4 more pods without touching the cluster. If we do a kubectl get service, then we can also see our GitOps demo has the type cluster IP. This means we also changed the configuration of our service. That's great, but what if you want to change more? And what if you want to have a more complicated deployment? Right now, we're deploying in the default namespace. That works to try something out, but it's not great, especially for production environments. I want to have all my applications in their own namespace. But before I can deploy them in their own namespace, I have to create them. So I have a dependency, and I can configure this also with Flux. This means first I'm going to deploy the namespace and then I deploy the application. Now we have 2 options. Either we update our configuration or we're going to delete it and recreate it. I like to delete it just to clean everything up I have running in the default namespace, get rid of everything, and then I'm going to recreate it. So now let's clean up the terminal and copy the command. We again use the ACK-configuration flux command, this time with the delete verb. We provide, as before with the show, the resource group name, AKS name, GitOps operator name. Then we tell it it's a managed cluster because we're using AKS. For an Arc enabled cluster, you would use connected cluster. And the yes parameter is just to force the delete and approve anything that's being deleted. Let's execute this. It's going to take a couple minutes probably. And once everything is created, then we recreate it with our dependencies. Our GitOps operator has been deleted and all the applications it deployed also have been deleted. You can see here, this happened because we have the prune option enabled before. Therefore, all the resources got deleted. To check this, let's do a kubectl get pods. And here you can see we have no pods running anymore. Let's clean this up. And now we want to deploy our application in its own namespace. So first, we have to update our application. So let's switch over to Visual Studio Code. Here we have the namespace. We just change it from default of to GitOps demo. So we did this for the service, and we also do this for the application itself. And also let's change the replicas back to 1. Then we commit this. So let's say change namespace, and we push this. So that's done. Now we can deploy our new configuration And in this configuration, we want to create the namespace first, and then we want to deploy the application. So let's head over to the terminal and copy the AKS configuration flux create command. That's the same command as before, except down here. Now we have two customization parameters. The first one is named infrastructure, and it references a different customization file. Here you can see it's in the infrastructure folder. I'm going to show this in a minute. Then the next one we have here the app. So that's the same one as before, except we have down here the depends on parameter. And that's the same name we have configured here. This means our app deployment depends on the infrastructure deployment. Therefore, the infrastructure is created first, creating our namespace. Then we are going to deploy our application. What's also important is if you're using a Linux, you have to encode the brackets here. So you would do a backspace before then, otherwise you will get an error message. If you take a look at the Microsoft documentation, you will also find it there. So if you use Windows like I do, then you have to remove them. Let's execute this. As you can see, now the CLI doesn't say anything that the extension is missing and needs to be installed. So all it does is now install our GitOps operator. And in a couple minutes, we should see our new namespace and our application running in this namespace. While this is being deployed, let's take a look at our customization files and how they look like. Back in Visual Studio, nothing changes for our demo application and its customization file, so that's the same. But now we have the additional customization file in the infrastructure folder. This again has the same API version. The kind is also customization. And in this, I have the resource and I reference a namespace.yaml file. And in this namespace.yaml file, I create the new namespace. So if you open this file, you can see it's again as simple as possible. The kind is namespace and it's the same name as we are using in our customization file. If I had a pipeline, then I might use a variable for the namespaces and then let the pipeline fill out the variable for the namespace and don't do it by hand. But for now, I just change it by hand, commit it, and then it should work as well. By now, the extension or the GitOps operator should have been deployed. So let's switch back to the terminal and see if everything is running as expected. Here in the terminal, we can again see there's a healthy, so that's always a good sign. Now let's do a kubectl get pods. There's nothing running the default namespace, so that's also good. Now let's do a kubectl get namespaces. Here you can see we have the GitOps demo namespace. It's less than 2 minutes old. So that's what we wanted. We created this namespace. Now let's see what's running inside this namespace. So we do a kubectl get all and we provide the name of the namespace. Here you can see we have our GitOps demo pod running. It's a bit more than a minute ago. And we also have our service, which is of type cluster IP. So with this, we created our namespace and then deployed our application. And you can extend this further and further. So for example, you could deploy the namespace, then a database, a front end, a backend, everything you need. And then you just configure these dependencies between all of them. You can also have more than one file referenced in the customization file. So for now, I only referenced either the namespace or the app. But for example, if you have several applications that can run independently, but you want to deploy them all at once, then you can reference them as well. In the beginning of the video, I said you can deploy YAML files or Helm charts, but I couldn't get it working with Helm charts. Back when I started using the GitOps extension, everything worked, and this time I tried it and it did not work at all, and I didn't get anywhere with the error message. But I also have to admit, I didn't look too much why it's not working. For today, that's everything I wanted to show you. It's not too much. Let's switch over to the presentation again and recap what we did so far. To conclude, we are back at this overview. What we did today is we made some changes in the application repository. We deployed them in one repository, so I didn't have an application repo and a Git repo, so it was just one, but I made the changes, I committed them, and then our Flux operator saw these changes, downloaded them, and applied them in the cluster. Therefore, I could have automated deployments without actually accessing the cluster. You might have heard it during the video. I'm not too happy about the extension. The documentation of Microsoft is quite bad. They just provide really only the basic information. I couldn't get the Helm deployment working, but also the Flux, the official open source project, seemed confusing to me. This might anger many of you, I guess, especially if you come from the DevOps side and you used to work with it. I'm sure it might be a great tool. I have a development background, I do architecture, I like DevOps, but I don't do it full time. So that's what I wanted to show you, that for me as a developer, and I guess there are many developers out there who have to deploy the application themselves, but are not full experts with it, you might have a hard time. Luckily, there's another tool, the Argo CD. There's also a GitOps extension with Argo CD in preview from Microsoft, and I've already tried it and it worked great. Also, for me, the documentation was easy to understand, and next week I'm going to show you how we can use it, how it works. Also, the documentation was easier to understand, and it comes with a dashboard where you can click around, and it made me happier than I want to admit. So if you're interested in the whole topic, I think GitOps is a great approach to manage a Kubernetes cluster, and you should look forward to next week's video where we look into Argo CD, which seems to be an amazing tool. I hope, even though we didn't achieve too much today and I was a bit more negative than I like to be, I hope that you liked the video anyways. If not, leave a comment. If you liked it, also leave a comment. And I will see you next week with a new video.